Okay, hi everyone. So in this video, we will look at the 2012 A-Level Paper 2, Question 6, which is on hypothesis testing. On a remote island, a zoologist measures the tail length of a random sample of 20 squirrels. In a species of squirrels known to her, the tail lengths have been 14 cm. So she carries out a test at 5% level of significance, you know, to decide whether the squirrels on the islands have the same mean length as the species known to her. She assumes, this one's very important, she assumes that the tail lengths are normally distributed with standard deviation 3.8. This means that later on, we don't have to use central limit theorem to talk about the distribution of the sample mean. Okay, so for part 1, state appropriate hypothesis for the test. Okay, first of all, because the mu has not been defined, so please remember to define them. So let mu be the mean tail length of the squirrels in cm. So we try to be as specific as possible. Then later on, the null hypothesis H naught is 14. So the species known to her is 14 cm. And then we want to check whether or not is it the same. So we are proposing mu not equals to 14 cm. So we want to check whether or not H naught still holds. Okay, moving on to part 2. So the sample mean tail length is denoted by x bar. So use algebraic method to calculate the set of values of x bar, for which the null hypothesis, which is H naught, would not be rejected. So when random variables are not given to you, please define them before you use them, because if you do not do that, marks will be deducted. So let's X denote the random variable tail length of a squirrel in C. Okay, so test statistic. Under H naught, meaning we assume that H naught is true first so that we can use the parameter. X is normally distributed, mu 14, because we assume H naught is true, so we use 14 first. Standard deviation is 3.8 squared. Then after that, we want to find the distribution of the sample mean. This will give us mu as well, sigma square over n. So in this case, the sample size is 20. Now, for this question, the sample size is 20. It's not large. Large means 30 or more. But it is not an issue because we know that the population is normally distributed. So there is no need for us to use CLT. All right. Then after that, for those of you, who wants to standardize, you write it this way. Okay. So this is our test statistic. Then after that, level of significance, 5%. Okay, so in some JCs, right, the teachers only requires the students to write level of significance. But personally, I always tell my students to add one more phrase behind level of significance. That is your rejection criteria. So that later on when you are doing your working, you know what you are looking for. Okay, so the rejection criteria for 5% level of significance two-tail test is reject H naught if z cow less than z0.025 or z cow more than z0.975. Okay, so to help you visualize what's going on, because we are doing a two-tail test, 5%. So the critical region on each extreme end of the normal curve is 2.5% only, which is equivalent to 0.025. okay, 0.025. So this z value over here is z 0.025, and then the z value over here is z 0.975, because the area on the left hand side of the z value is 97.5%. All right. Okay. So to find out what z 0.025 is, you can inverse norm 0.025. The mu is 0, the sigma is 1, because we have standardized already. This will give you 1.9600 negative. This will give you 1.9600 positive. So these are the critical regions. Since H naught is not rejected, okay, the Z cow is in the white region. So the Z cow is between negative 1.96 and 1.96. All right, so we can sub in the values. X bar minus mu over this is 3.8 over square root 20, 1.9600, negative 1.9600. So you can bring the constants over, multiply the denominator over, then plus 14 on every side. So your X bar is between 15.7 and 12.3. Okay, so set of values, X bar is part of real number, such that, so this colon or this straight line, you can put colon as well, is between 12.3 to 15.7. All right. Then after that, part 3, they ask you, state the conclusion of the test in the case where X bar is 15.8. So the first thing you should do is compare 15.8 to what you have in part 2. We found out that when H bar is between 12.3 to 15.7, we do not reject H naught. All right, I repeat. If X bar is between 12.3 to 15.7, we do not reject H naught. Then in part 3, you tell me X bar is 15.8. This means that we are going to reject H naught because the X bar in part 3 is not what we have in part 2. All right, so for part 3, since 15.8 lies outside the set of values in part 2, we will reject H naught and conclude that we have sufficient evidence. Okay, every time you write we have sufficient evidence, you must write down the level of significance. Because you have sufficient evidence at 5% level of significance does not necessarily mean that you have sufficient evidence at 1% level of significance. So you have to write that down, sufficient evidence at 5%. I write short form, level of significance, that those squirrels on the island do not have the same mean field length as the species known to the zoologists. All right. So for part 3, you don't have to do any calculation. You make use of the answer found in part 2 to make a conclusion. Okay, so this is how we do question 6. So I see you guys in the next video for question 7, which is on P and C. All right.